Hello, everyone, and welcome to today's Solar 101 for Growers webinar. We're pleased to have Chris McArthur from New Zealand's Energy Efficiency and Conservation Authority, EECA, with us today to share practical insights into how solar technology can support horticulture businesses. Whether you're beginning to investigate solar as an option for your operation or looking for independent information to support future investment decisions, we hope today will provide useful insights and practical takeaways. Now I will hand it over to Chris and enjoy the webinar. Thank you.
Great. Going to share some slides. Hopefully they will come through. Basically, the idea of this presentation is a 101, so like a beginning look at solar. But hopefully, you come away from it with a better understanding of the technology and where your next steps might be if you're looking to adopt it. So, I will give you a quick 101 on EECA. That's not why you're here, but so I'll make it quick. EECA are the Energy Efficiency and Conservation Authority. We're a government entity set up by an Act of Parliament 26 years ago. And we've got a mandate to promote energy efficiency, conservation of energy and renewable energy. And so that's why we get involved in things like solar on farms. I'll give you a little bit of background on our energy use in New Zealand. As you can see from this slide, we've got the bulk of our energy use is oil, and which is all imported, which is not a great thing, and that's for transport. Our electricity is highly renewable, which is fantastic and a real advantage to New Zealand, but oil is probably the biggest challenge. Now, our electricity generation, as I mentioned, we've got a lot of hydro, and we've got some good geothermal and wind happening. But solar, New Zealand are a little bit, we're laggards in the solar space. We've only got about 1% of our electricity use is solar. Countries like Australia, they've got 20% electricity is solar, so they that's why we see there's a huge opportunity for New Zealand to invest in solar and play a bit of catch up with other countries. So just tell you a little bit about the electricity market in New Zealand. It's an interesting market. It's got some little quirks. So basically it's made up of generators who generate the electricity through the hydro dams, geothermal plants, power stations. Then that goes into Transpower's transmission network. And then there are 28 different lines companies around the country, the likes of Vector and Orion, that are what we call electricity distribution businesses, or EDBs, and they take the electricity from Transpower and distribute it to customers. And then we've got the retailers, who are the companies that are allowed to retail electricity, or sell you electricity. And New Zealand's quite unique in the fact that we've got what we call gentailers, who are at both ends of that market, so the generators and retailers, and that's the big companies, the Genesis, Mercury, Meridian, Contact Energies. But it does lead to some quirks, which I'll get into a little bit later on. But it does also lead to a very difficult market to break into, because if you have a dry year and wholesale prices are very high, the gentailers make money on their wholesale arm. But if you have lots of hydro generation and plenty of water, like we have at the moment, the wholesale prices are very low, but the gentailers make money on their retail arm. So very hard for little companies like Electric Kiwi and Ecotricity to break into that market, because they'll have a year where it's very difficult to manage. So that's the market we have. All right, getting started with solar. So just basically, how does solar work? So basically, sunlight hits solar panels, They've got a layer of silicon in them, or a couple of layers of silicon in them, and that generates DC electricity, direct current electricity, which then goes into an inverter. And the inverter takes the DC electricity and turns it into the same AC electricity that we have in our buildings everywhere. So that basically acts like a generator. It turns that DC into AC. And then the electricity, I like to tell people to think of it as like water. It goes the path of least resistance, and the path of least resistance for electricity coming out of the inverter is to the nearest point of work. So that could be charging a tractor, like in this picture, or it could be a fridge in a house. But if there's no work going on in that building or farm, then it will go out onto the grid, and it's fed out onto the grid, or it can go into a battery. So you can have a battery, or you could think of the grid as like your battery, where you export it out into the grid and you import from the grid when you don't have much solar generation. Now, the tricky thing is, going back to the electricity market with all those different steps there, the gentailers will typically not pay you what they charge you. So when you export electricity, they don't pay you the same rate as what they charge you. And that seems very unfair, but it makes sense from their point of view, is because a lot of your bill is made up of that transmission and distribution part of the electricity market, and the gentailers can't get a credit for what you are not transmitting or distributing. So, like I say, it seems unfair, but there is a reason for that you don't get paid. But this is why we really encourage people to size their systems for self-consumption. So not seeing what you generate as a potential revenue stream. That's going to be tricky into the future. We want people to size it as a way of saving on their power bill rather than making money. And a lot of the reason we do that is because we look at the Australian market, and at the moment, for what you get, retailers over there are often not paying a cent for what you export onto the grid. So we'll kind of look at that more mature market where they've got a lot more solar, and take some lessons learned from there. You really want to size it for self-consumption. So you can see there that we've got a lot more. Australia has a lot more solar than we do, and they have that for good reason. They subsidised it, but they had a lot more coal generation in their electricity mix. So for them to get their greenhouse gas emissions down, they were focused on electricity. New Zealand hasn't historically been focused on electricity because our transport and our stationary heat, so like process heat in freezing works and dairy factories and that sort of thing, has typically been a bigger source of emissions. Yes, and it's just another graph or picture to show, New Zealand's got a long way to go, but I like this picture because it shows that Australia got a very mature solar market, one of the leading markets in the world. And the good thing is we share a lot of standards with Australia. So the troubles and the challenges they've been having with lots of solar uptake, they've addressed, and they've updated their standards around things like our electrical standards and inverter standards, and we just copy those standards. So we've kind of solved the problem before we've got it, which is in a good position to be in. So New Zealand's quite lucky on that front. Okay, now we've done a lot of research on how people adopt solar, and consumer research and farmer research, very similar. The journey, it can be a very long journey from where people start looking at solar to when they actually make a decision to go into it. Key difference we've found with farmers versus consumers is farmers are time poor. So they have less time for that research. So from EECA's point of view, we're trying to get simpler information out to farmers. But yeah, it's a very long journey. And I think talking to people who've got solar is a really good place to start. I'll talk about batteries. So batteries are a tricky one. We think, basically they cost money, and they add to the upfront cost of the solar system. So they actually make the payback slightly worse. But in saying that, talk to a lot of farmers, particularly dairy farmers, so not applicable here, but where power outages for them are a real headache. And solar doesn't provide backup unless you have the battery. The battery is key to getting that backup. So traditional solar systems, if the grid goes down, they switch off. Battery systems will put in place what's called an automatic transfer switch. And basically, if the grid goes down, they switch off the grid and basically become a small microgrid. So depending on your processes, if you've got processes where electricity is key, I'll talk back about dairy farmers again, because if in the middle of a milking you have a power outage, all the cups fall off the cows, and that's a nightmare. So the extra cost of the battery is pretty easy to justify in a situation where you've got a process where electricity outages are a real headache. But that might not be so much the case for growers, where an outage is just an inconvenience, not a real headache like that. So, yeah, our advice on batteries is pretty vague. It's basically, if outages are a concern for you, then definitely consider a battery. But if not, then just go solar only, because that's the better economic decision. Sorry, I'll talk about this graphic a bit more. Basically, that's just showing that the battery technology price is coming down, and it's coming down pretty steadily, and I can't see that changing. It will continue to drop, I think. Mostly driven by Chinese production of EVs. That's really pushed the cost of batteries down. And there's new technologies coming online all the time, and the chemistries are evolving all the time. But the one big development that everybody's most excited about for EVs is solid-state batteries, which are inherently more safe, last longer, but at the moment are just more expensive. So people are trying to figure out a way of making them less expensive. And I just want to touch on the idea of thinking of storage not just as a big battery. Energy storage doesn't have to be batteries. Your hot water cylinder is energy storage. So we're seeing a lot of farmers and homeowners looking at their hot water cylinder as just a battery and putting it on timers and having it heat while the sun is shining. So, yeah, energy storage is more than just a battery. One of the exciting bits of the technology is virtual power plants, which is where an aggregator, a business, will control a whole bunch of batteries at once and get them to basically collectively act like a power plant. And California have successfully trialed this, and with SunGrow and a company called SunGrow and Tesla, who you've probably heard of, basically seeing if they could get all their batteries to act like a power plant to shave off a peak. And they did. They successfully did it in California. So it's something for you to consider. If you do get a battery, would you want to work with a virtual power plant provider and give them control of your battery, or would you rather have it control yourself? Now, we have a program promoting solar on farms, so I'll talk a little bit about that. We've recruited 37 demonstration farms of different farm types up and down the country to install solar and batteries. We require it be battery, and we require to include a battery because it's very easy to model solar output. We've got good weather data, and we know what solar can deliver. The batteries are a newer technology, and we didn't know how farmers were using them. So it's we've got these farms which are all installing solar and batteries. They have been kind of like started this year. Some of them have completed their install, some of them have not. and we're collecting data on that, and we're going to make that data available through our website. And the intention is that a farmer could just go onto the website and go, okay, I'm in the Waikato. How are the farms in the Waikato performing? Or I'm in Southland. How are the farms in Southland performing? And they'll also look at the different farm types as well. It's like an arable farm is very different to a dairy farm. So, do I need such a big system? Hopefully that will be very useful data to farmers. We have required that the farmers hold open days as well. So we'll be working with the likes of potatoes and others to promote those open days. So you can come along and hopefully see a demonstration farm and hear from the farmer. We've basically, a lot of the farmers have said, don't want to do the open day until I've lived with it for a year, which makes complete sense. They don't want to endorse something that they haven't been through those seasonal variations and that sort of thing to see how it works. And there is a big difference between what you get in summer and what you get in winter. So, so depending on your load, a lot of the farms we see actually have a higher summer load. Most of the farms are, their production is in summer, so they're using a lot more electricity in summer. So that's a good match for solar. One of the biggest traps we see, or mistakes we see for farmers, is this multiple ICP issue. So a lot of farmers have different connections. So electricity connection is called an ICP, and normally each ICP has its own meter. So what we have seen is situations where an installer will come along to a farm and go, oh, that barn roof is fantastic for solar, north facing, nice and easy, we'll put solar on the north facing barn roof. But actually that shed has its own ICP, and the big electricity users on the farm, it might be an irrigating pump or something else, has its own ICP as well. So what you get the situation there is that the solar is generating fantastically, and the shed that uses hardly any electricity, so it's going out into exporting onto the grid, and they're getting paid maybe 12 cents for what they export. Meanwhile, the irrigator is using electricity while the sun is shining, but they're being charged maybe 30 cents a kilowatt hour. So that's not a good outcome. So what that's an easy mistake for a lot of farmers to make. So we're trying to raise that as an issue, but also something worth considering. If you are looking at solar, think about your connections. Maybe one of our demonstration farms has successfully retired an ICP. So they talked to the network company and said, look, we've got 2 ICPs, we just want one. And their network company was happy to knock it down to 1. So that's, I was given a list of questions about potential mistakes. That's definitely one, is looking at what connections you have and what you can potentially rationalize, and which connections have the most load. We also have a bunch of residential support, and I don't know about potato growers' electricity use, but my suspicion is that it is mostly diesel that is the pain point, or your energy cost. And I imagine it's the same for like a lot of sheep and beef farmers. They're more akin to a large residential load than a big dairy farm. A dairy farm might be using $100,000 worth of electricity a year. Picking the growers are lower than that. So actually the residential advice we have might be quite applicable to you. So we have quite a lot of residential advice on our website that you're more than welcome to, well, I encourage you to go and have a look at. And one of the other things we're doing is we're getting an approved products list. Like I mentioned, we can look to Australia, where they've got a much more mature market over there, and they have an approved products list. But we were given feedback that people wanted something that was New Zealand specific. So we are basically have an approved products list. So if an importer of solar technology wants to sell products in New Zealand, they can apply to be on our approved product list, and we'll make sure that they have all the applicable standards that we'd expect, warranties and that sort of thing. for solar products in New Zealand. And that's good. That a lot of these companies are companies that you wouldn't have heard of before, but they're still reputable and making good products. So we can do a bit of a sense check for you and give you, you can check that their products are on our approved products list. Just get peace of mind that it's not come off Temu. Basically, is the intent behind that. We also have an 0800 number for growers, or farmers and growers, specifically, there to provide impartial advice on solar. I've got that email address there as well. So we're basically offering a free service. As myself and two of my colleagues, Sarah and Karen, you call that 0800 number, it'll go to one of us, assuming you call it during office hours, and basically we can provide impartial advice on solar. We won't go to you, you should use the supplier over another, but we'll just give you our impartial advice on what we think is good. Now, we've seen hundreds of quotes that solar providers have provided, and we can give you feedback on what might be nonsense or what might be a good quote. We've got a lot of strong feedback from farmers that they have good BS detectors, farmers and growers. So they basically, the vendor is pushing their product, and we can provide impartial advice on whether or not that product is right for them. Now I've got some of the questions that were sent in earlier. Benefits of going for solar, it's really a cost-saving exercise. Well, there's two benefits, really. There's the cost-saving exercise, and then there's the potential resilience of not having power cuts. Now, the concern I have about saying there's a resilience benefit is if you just get a battery and you get solar, most of your outages are probably caused by weather-related events. So it's likely to not be sunny when there's a weather-related event. So that's something you have to consider is, what will the state of charge of my battery be when there's an outage? So most of the battery vendors out there have a system where you can say, I want you to go in self-consumption mode, where you are saving what I generate and then discharging to help me meet my loads. But you can also put them into backup mode. Some of them have what's called a storm button, which is not a physical button. It's a thing in the app, which basically, if you get a weather alert, you can say, actually switch to backup mode. And that way the battery will just stay fully charged, ready for the outage. So just a caveat around when I say there's cost-saving benefits and resiliency benefits, the resiliency benefit is something that it's not just it's there when you need it. You have to have a think about that and learn to work your battery, basically. There is a carbon emissions reduction, but due to New Zealand's high renewable electricity, it's not a huge carbon reduction. It's not the equivalent of taking a car off the road in most instances. Payback, if you've got a high electricity load, you can get paybacks right down like 3 or 4 years. In most instances, we're seeing like 5 to 7 years. The battery does push it out. You may be looking at 8 or 9 years. You can depreciate the product, so it's an asset on your books. So there's a little bit of a tax benefit there, which can save, push the payback down maybe a year or so, get back down to that 7-year mark. Sizing is really tricky, and it is quite crucial to getting a good payback. You don't want an oversized system where you're just exporting and getting paid 12 cents. And big caveat there is you're getting paid 12 cents now from a lot of the retailers, but like we saw in Australia, that's going to be less and less. So if these bigger solar farms come online, my suspicion, and I don't have a crystal ball, my suspicion is that the payback rates you get not the payback, the feed-in tariff that you get will reduce. Basically, the wholesale spot price for electricity in sunny days will reduce. Mistakes we've seen, I've mentioned the ICP issue, making sure your connections are rationalised. That's a big one. We have had one of our demonstration farms who basically, and I don't know that this is strictly speaking a mistake, but it's something to consider. They used their Sparky, the Sparky that knew their farm and that they trusted to install solar. And he was getting interested into solar, but he installed it in a place that was going to be very dusty and very difficult to clean. And I just think using a more experienced solar installer, they probably wouldn't have made that mistake. So that's a thing to consider. So ICP issues and also farms' dusty environments, being able to put it somewhere where it's easy to clean is important. But I also think using an experienced solar installer is probably a good piece of advice. I got a question about funding available for EECA. There is no funding available. Sorry. There's good low-cost finance available from like said ASB, and I mean if you shop around the banks, they often have sustainability loans, and there is every political party at the moment is saying we're going to have something where you could put it on your rates, which I think is a fantastic initiative. But at the moment, there's no funding available. There's just low-cost finance options, and potentially putting it on your rates, which is essentially a low-cost finance option as well. First step, I would make a plug for our website. We've talked to a lot of farmers. We've got a lot of information that is farmer and grower specific on our website. And then it's a matter of going and getting some quotes, talking to some installers. And then, like I said, we've got this 0800 number, free advice on, we could compare quotes for you. Because in a lot of cases you get a quote and you don't know what you're looking at. They're not renowned for being clear. I'll be honest. And also had a question about what will solar look like in 5 years' time. I don't know. There's things that change in this industry so quickly. It's a real dynamic industry. So I think solar will just be a little bit cheaper and a little bit more reliable and a bit more efficient. I suppose the big difference I see in 5 years' time is the battery technology. So Australia have launched a huge subsidy for home batteries. So they've got 500,000 homes with big home batteries. And that's really changed the battery landscape. And we, again, because we're neighbours, that'll probably impact our market as well. So we may see really, really cheap batteries in 5 years' time, but we may also see those batteries not necessarily being something that sits beside your house and powers your home. They may be on wheels. So you might be the tractor or your ute might be a battery that can be used like a home battery. So I think that technology is very likely to come. So that's covered your questions, and I think it's a brief or broad 101. I'll pass back to you, Sherry.
Thank you, Chris. That was really valuable information that you shared, and we really appreciate you taking the time to share that with us. Did you have any final words, Chris, before we close it off?
No, just thanks for the opportunity to talk about solar.